how to find the primitive function of arctan of x, this expression here, and we want to find the primitive function by integrating. So what do? We're going to use a little technique called partial integration. And partial integration is done by a formula looking like this. Let's focus on that for a little while. So if you have an integral of two functions, f of x times g of x of t of x, then partial integration of this is f of x times g of x minus f of x times g prime of x. So what we can do is use partial integration as like middle step for doing this evaluation. So what do we get then? But this is, if you look at this, you can see that it's only one function, but there's two in the partial integration formula. Well, what if we introduce a constant function where g of f of x equals 1? So if we rewrite our original expression here, this, so 1 times arc tangent of x. Then 1, this is obviously the same expression as if the 1 wouldn't be here. And we get a very simple f of x to find. So if we do this down here, we get the primitive function of 1 is x. And then we just put arctan here. Oops, I shouldn't write so close to the edge. I'm gonna erase that away, and rewrite it so it looks better. I just need to move it up here for my sake. So arctan of x minus the integral of f of x, so that's x, times the derivative of arctan of x. I just made a video where we found the derivative of arctan of x, and it is 1 over 1 plus x squared. So 1 over 1 plus x squared. That's it. Having done this, we have made a little simplification. We have done a partial integration of this. So although we didn't know how to find the primitive function of arctan of x, now we just have to find the primitive function of this instead, because we've already done this part. So before we can move further, we need to find and have a little focus on this integral here. Nice straight line. Let's remove it. So let's focus on this for a little while. Is that beautiful? No. Just let me make a little sign here. So let's calculate this integral. We could call it, let's call it I for integral. So if we go on to calculate I, which is equal to the integral of 1 plus x squared, denominator, dx. That's the more correct way to putting it. How do we do this? We would probably want to use something called substitution, something I also talked about. So the substitution we're going to make here is substitution u equals 1 plus x squared, giving us the derivative of u to be du equals 2x. And implementing this substitution gives us that this is the integral of 1 over u, obviously, times du over 2, because we have 2x here and we only get 1x here. So if we divide this by 2, we get that to be equal to x. Beautiful. Further simplification here gives us that we can take out a half from here. You can always remove constants out of the integral if you want to. And then we get 1 over u. The u, like the brackets, the parentheses. So what's the primitive function of this? Well, this is a standard primitive function. So this is very easy to calculate. This is just the natural logarithm of u over 2 plus constant. So that's the value of the integral I. So then we have to just replace this in here. So x times arctan of x, let's remember that. Let's continue to whatever we had here. And got x times arc tangent of x minus the value of I, which was this. But before I do that, let's resubstitute. So u equals 1 plus x squared. So we can replace u with 1 plus x squared. We do that immediately here. Natural logarithm of 1 plus x squared over 2 plus constant. And that's the primitive function of arctan of x. So this is equal to what we started with. Like this. And the problem is solved. Any questions? Ask them in the comments. You can also ask me for some requests on math problems you want to have solved, and I'll see if I can help. Best of luck in your studies. Bye bye.